My name's Awais, or you can call me Desert Thunder. That's kind of what I go by everywhere. Um, I'm an open source developer from Austin. Um, and yeah, this is my first sort of soiree dive into podcasting. Um, for the past month or so, I've been posting these daily devlogs on a platform called Leaflet. It's really cool. It's built on top of um, the at protocol, and yeah, it's pretty awesome. You can check mine out. Link in the description, and all the projects I'm going to talk about are in the description as well. So if you want to, give me some feedback, make fun of my code, whatever, it's your prerogative. So have at it. Yeah. So first of the first of the two projects I'm working on these days is called Knowledge Lab. Um, it's a desktop application built with two pretty awesome tools. The first one is Whales, which is this Golang um, uh, desktop application library. It's sort of like Tari in the Rust ecosystem, where the application is built like by it doesn't bundle a browser engine the way Electron does. Instead, I think it binds to a native JavaScript engine, um, and yeah, and so you can use kind of any web front end you want, vanilla, React, Vue, Svelte. I've opted for React, sort of, using uh, this alternative compiler for F Sharp called Fable, which is really awesome. Lets you write Elm style code um, for your React applications. It's pretty cool. So it's got like this nice like HTML DSL exposed through a library called Feliz. And it's just like any other Elm application, or you know, if you're familiar with like Charm Bracelet, they use the Elm architecture. So yeah, you just define the structure of your state and a bunch of messages, and you mutate state based on that. I think in Elm it's generally called your model. But yes, it's the model view update architecture. It's kind of, I think it's what Redux uses, but they call your update function is your reducer, and yeah, there's a few other names for it. But yeah, so that's like kind of a overly verbose but high level overview of like what Knowledge Lab is built with. What it actually is it's an entirely local first note taking application, sort of built upon um, uh, the the spirit of like Obsidian and Logseek. I think that's how it's pronounced. Um, Obsidian is a great tool, and what's awesome about it is that it's all in plain text. And so, like when I used Obsidian before, I just did like a flat file of Markdown or flat directory of Markdown files. You can sync with Git, Dropbox, whatever you want. And I think kind of my only beef with Obsidian, and it's not really a huge one, is the fact that it's like proprietary. I kind of wanted to make a tool with similar capabilities that's open source. And uh, so the idea is to just provide like a more transparent version of what's already out there, um, and make a tool that I would use. Um, um, so yeah, that's sort of the idea there. What I worked on pretty recently was um, search. So last week I made a small CLI in Golang called Okapi Note, which is cleverly named after the Okapi BM25 algorithm. So um, BM just meaning best matching. It's what search engines use to like score how relevant a document is to whatever you're searching for. Um, yeah, link to that will be in the description as well. Um, but yeah, so I learned about this algorithm called term frequency inverse document frequency, and um, kind of led me to BM25, which is a ranking algorithm that sort of builds on top of it. So yeah, just to learn how it operated, I built a little thing to like index a bunch of files and generate some JSON to search against. So yeah, I implemented that. I had started implementing that in the Wales portion of Knowledge Lab, but what I ended up doing was just using a library. I think I might do that as well for front matter parsing. I'm using uh, Goldmark for Markdown anyways, but I have like this, I have like a pretty simple scanner function around a scanner to parse, the parse like a block, YAML block. And I think hopefully I could find something that does YAML and TOML, and even JSON. Although I've never seen people, I don't think I've ever seen JSON front matter, but that's got to be a thing, right? Yeah. So yeah, I worked on that. Kind of thinking through like if I want to support syncing like out of the box at all, like like yeah, with Obsidian, there's a Git plugin. That's kind of difficult to use on phones. I have no idea how it would work on an iPhone, and I think on Android there are a couple apps you can use to like sync a folder with instantiate a Git repository, but yeah, I don't know how it would work. I'll have to look into that. Yeah, hopefully there's like something with Flutter, but yeah, that's all like kind of down the line. Like I'm still focused on the desktop app right now. Yeah, and so I was just thinking through like syncing strategies, like there's could use the at protocol, yeah, natively support Git or something like Dropbox. Yeah, the other project I've been working on is Beacon, which is I it's simply put, I think it's a type checker and a LSP implementation for Python built with Rust. Yeah, I guess the memes kind of write themselves there. I don't know if it's blazing fast. I'm still in the process of setting up like benchmarks and profiling tools. But yeah, so the two things I did for that yesterday were I expanded on, or I didn't expand on, I sort of re-implemented the Tarjan algorithm for uh, module or workspace graphs. I had already done this like at an intra module level, but not like not like for a workspace. Like a lot of multi-file stuff is just not implemented in my project. Um, so yeah, I actually wrote a little essay about Tarjan on my Substack, and I post the link in the description. Um, but yeah, I it was one of the things about this project is that it's pretty complex. The If you've ever seen the LSP, the language server protocol specification, it's super long. The JSON types, the schema is colossal. So there's a lot of code, a lot of test cases, and one of the things that you have to do in a project like this is construct ASTs, and so you know I I don't know, I guess I finally came to my senses and started using like JSON, and embedding it into test modules, uh, to uh, to keep the test shorter and to keep like the fixtures sort of isolated. Um, it Yeah, I think one file had like a 2,500 line diff just because I'm not using the nightly release of Rust, and so like the Rust formatter, I don't think supports um, you know putting struct fields on like single lines. So like I would just have like this giant data structure in all of those tests, and it would be for code that was like it would be for Python code that was like 2 lines long. And granted, like an AST is pretty complex structure because you're tokenizing sort of all of it, but yeah, it was still kind of untenable. Changing a field, I would end up completely destroying my diffs. So yeah, I ended up making a bunch of fixtures. I wrote my first like quote unquote production macro for those fixtures. It's just kind of, I think it wraps include uh, include str, I guess, reference string. Yeah, it's pretty awesome. Yeah, and then a couple other features I worked on that I want to talk about. Um, uh, the first one is it's taint analysis. Um, so I wrote just wrote a little blurb about it because it's got kind of a silly name, but taint analysis is basically, it's like static analysis that goes through your code, and it labels certain inputs as tainted and tracks how it flows through your control flow graph into potentially like unsafe syncs. So these are things that like interface with like external systems. So when you look this up, it'll commonly tell you things like IO or SQL, or things like eval. And so you want to analyze this stuff to like protect against uh, to I guess like help a developer be more defensive and properly sanitize their code. Um, the second feature, or really the prequel to this, is because taint analysis sort of builds on this, is type propagation. So type propagation basically is the process of following type information through your entire like graph representation, so that like when you find a type in one spot, you can apply it to different elements and symbols indirectly or directly dependent on it. So it like just helps you uh, trace the source, um, and like you basically helps you trace a type. And again, this is like really important to like follow through when analyzing tainted code. Um, the other thing I did yesterday that was kind of silly was yeah, playing. So this Knowledge Lab desktop application, it's gone through like many iterations in the past. Like if you look at the commit history, the first day or two is really ridiculous because I had a lot of this code already. I just kind of like put it together. Um, I just took it from those other projects and um, I just basically copy pasted from my own computer into a new project with a few different like design decisions. And one of the iterations of that was using Iced, um, which Iced is pretty cool. It uses the Elm architecture pretty effectively. It's I think it's being used by Pop OS for the Cosmic desktop. But yeah, so I made a really really simple app for like my Twitch channel, you know, on which I just play RPGs. So basically, you like upload an image, and when you're talking into your microphone, it acts sort of like Discord does, where like a green outline pops up. So or a glow. I don't know, whatever you want to call it. The the point there is, sometimes I want to turn my camera off, um, and but I still want like viewers to know that I'm there and talking in some way. It makes like the avatar look a bit more lively. But yeah, it's a pretty simple application. It like interacts with like it uses this library called CPAL, um, to get like audio input device information, and then using like Ice Canvas create like draws a waveform. Um, it does two things. It can draw a waveform if you like open that, but it also just draws an outline behind an image. Um, so yeah, that's sort of all the stuff I did today. Again, everything is in the description. All the things I've talked about, my Substack, um, and yeah, Substack source code. Yeah. Any feedback's welcome. Thanks for listening.